Hello guys, this will be a start. I don't know how many parts is this going to end up being, but it's going to be a start on schematics. I'll probably just call it Schematics 101. I thought today kind of go over some symbols, any that I'll miss a lot of symbols. There's by far more than what I'll be showing you. But as we get into schematics, anything I know I haven't actually covered, we get to that point, I'll point it out, discuss it, and so on. But some real just basic things here, and you may not see a lot of these, a lot of the ones I show. You'll see more, a lot of schematics are more generic. So anyway, here we go. We'll start off with a couple of different ways of drawing resistors. This is actually the rectangular box is more of a newer way of doing it. I'm not sure exactly when it came out. Like I said in the previous video, I'll be using their schematic as part, just showing some differences. But the Kaiser that I'm working on, it was like 56 or 57, and they did draw their resistors. They even got a little deal down here to talk about them, but they did draw their resistors by rectangular form. As far as in this country, in the States, I'm not sure exactly when this was started, and we moved away from this. So, but suffice it to say, a lot newer stuff. If you ever work on anything newer and you look at the schematic, you'll probably see more of something drawn like this for resistors, and they can be labeled either as, a lot of times you'll see like R1. Sometimes they'll give you a resistance value, say 1K. That's a nasty looking K. But, or 1 meg or whatever. They might even give a wattage rating. When I start looking at this one, we'll discuss. I don't know if you can see it, but they put various different lines to denote the wattage sizes. So, and sometimes what they'll do is if it doesn't have any size on it, it may be a certain, the parts listing or in the schematic will tell you that it may be like they're all half watt or a quarter watt unless otherwise designated. And they could very well easily put like a 2 watt or 1 watt or something like that. But it'll either be a squiggly line or a square box depending on how new or what you're working on. And they will have some sort of labeling. They may have nothing more than just a schematic number like R1, R2, R3, and then you have to look in the parts list to see exactly what size resistor they are. So one other thing about resistors, when you get into something a little newer, older listings in the parts listings and on schematics and stuff, let's say you got a 1.2K, you'll see it wrote 1.2K. In newer schematics, and when I talk newer, I'm talking more contemporary, 80s, 90s, whatever, and newer, they went to doing this for a 1.2K, putting the K in there. And the reason why they did that was, excuse me, I know you're very familiar, a lot of you are, with nostalgia error and sometimes bad scans of schematics, and sometimes that dot will be very hard to see or be completely gone. And you're looking at it and you're going, well, is that 1.2K or is that a 12K? So that's one reason why they did this. Putting a full K, or if it's like a 1.2K, putting that K in place of the dot makes it a lot easier to see. And if you got a poor scan, it makes it still easier to read. So, and if it's meg, they'll put 1 meg or 1 M, capital M, and so forth. Now, speaking of letters, if it's omega, they usually use an omega sign in there. Like 1.2 ohms. Omega sign is like that. Speaking of K and stuff like that, when you're working with older radios, say back in the 30s, K was not, they didn't use K, they used M. So you'd have like a 1 meg, or 1K would be 1 M. If they wanted it to be a 1 meg, they would do it drawn out. I gotta get down there. So in like 1930s schematics and that, this would be 1,000 ohms and this would be meg ohms. So don't get that confused and you see 1M or 10M or 50M or something like that on the schematic and thinking, wow, they're using some large resistors. No, it means 1,000, and it actually comes from the Greek letter M for 1,000 for the Greek numbering system, the old letter numbering system. So I thought I'd point that out too. Now, let's see. Oh, one thing about, if you do get a schematic that it should be like 1.2K or whatever, look at some of the other numbers. If you don't see a dot there, because that dot, these were typed in, so that dot would take an actual character spot when it's typing. So, when you type a letter, one letter, then the carriage moves over, type another letter, and then it moves over. So that is 1.2K, but a 12K would be real close together, like this. So if there's a fair decent space compared to some others that you really do know the value, or they're closer together, then most likely that does have a dot in it, just the scan was terrible. Now we'll work on with a little bit about capacitors, some of the various things you'll see. The basic fixed capacitor is just 2 straight lines, and then you got your wires connection to them, and they can be turned this way or they can be turned whatever way they need to on the schematic. Sometimes on electrolytics, which are polarized, they will have just 2 straight lines, but they'll put a plus. They might even put a minus. Sometimes, a lot of times, the minus is omitted. Another way of drawing it, which may or may not have the plus, Philco like using these, is draw it in with a short bar and then a kind of a cup and a line. Well, the short bar is the positive. The cup kind of represents the can of the capacitor. Your positive plate is your positive plate's inside the can, and the can makes up the negative. Another way is to blacken in real thick bar for positive. Now, this is not always the case. Sometimes that may be reversed. I have seen schematics where they either blacken it or draw lines in there to make it thicker, and it was actually the negative. So standard rule is supposed to be that'd be the positive. Another way of drawing them, electrolytic, is a straight line with a curve. The curve is supposed to still represent the outer kind of curvature or casing being negative and the straight line being positive. Another way, kind of more of the lazy man's way, is kind of a alternative to this. You just draw a straight line in and then have your cup, the straight line being positive. And for variables, there's actually more than this, but these are the basics. You can have just a straight line going across. Technically that should be for like a trimmer and or patter, but I have seen it used in some schematics for the tuning condenser. Tuning condenser properly should be drawn this way because basically that's what it's doing. These are the movable plates, and they're basically kind of, you can see, like, you know, they're rotating, so in a curve or an arc. And then more of a trimmer or even temperature controlled, where you have a capacitor that comes in and out as its adjustment, will be drawn this way. There has been some known types where they've drawn an arrow like this instead, which is a possibility. Now, as far as inductors and coils and transformers and the like, and I'm hoping to get pretty much most of that on here. There's various techniques, just straight little humps, kind of more of a curlicue. Another way is, generally they draw them like this if they're meaning for them to be the plane of the coil. In other words, the winding may be coming around like this, and it's in parallel with something like usually the chassis, but sometimes they might draw it like that. There's also a means of drawing it where, like for a coil antenna coming up like this, you know, like the loop antennas on the back of newer late 40s into the 50s radios that have on the back plane, the back that you take off will have a loop antenna in there. This is usually denoted this way. May even have more loops in it, less loops, whatever. Another way of drawing a coil is just to blacken it in. And if it has a core, these are more like air core. In other words, there's just nothing in there. It's just a tube with wiring, or maybe even just the wires out in the open and no form whatsoever. But if it has some sort of core in it, it can be iron, it could be other like pressed metal or something of this nature, a powdered metal pressed, like a slug or something. They'll draw lines to show a core. As far as transformers go, you'll see a lot of IF transformers, and basically a lot of your coils in your oscillator and stuff of this nature, antenna coils and things like that, are actually transformers. They actually have a primary and secondary for most of them, but they don't have no core. They're made on a tube and wound on a form tube, just like this. So there's nothing in there, and so they'll be drawn like this. And if you know, sometimes they have different numbers of windings, so they might draw one side with less loops, just to kind of denote that. If they have a core, then they'll put the core in there. Sometimes they'll put the core, if it's like a ferrite core that can be adjusted, they may draw it straight inside the loops and then put a line across with an arrow. They could not even have that showing there and just put an arrow, or they can not have it showing and put like a, I call it T-pin type affair. There's others where instead of drawing it like this, they draw it like this. So that's some of the basic ones. Now some of the tubes that you'll, more common tubes, sorry about that, that was a scanner going off fire. in one of the counties. Anyway, some of the standard tubes that you'll run into. Now, I didn't show any type of heater in there. A lot of times they're denoted like this for if it's indirectly heated, where it's actually got a metal cathode and then a heater. They can be drawn, you know, if they're what they call directly heated. They'll just show the heater like that, or the filament, which, by the way, the proper terminology for indirectly heated cathode, where it's a separate cathode from any type of filament, then the filament is called the heater. If it's directly heated, in other words, the filament itself, or that wire is actually also the cathode, then it's called a filament. But this and this is a diode tube, and you know, basically these are used for rectifiers and detectors and things like that. You can have half-wave rectifiers where it's just got one plate. They can draw two plates in here. This is your plate. They can have two of these in here, and that would be a full wave. They may also draw them with two cathodes showing. That doesn't always mean that those cathodes actually go to separate leads. They may or may not. You'll have to look up the tube for that in the manual. The next level up is the triode tube, plate, cathode. Again, I didn't show any type of heater in here. And any of these tubes can also be directly heated, where the cathode would actually be the filament, or they can be indirectly, where they have a separate cathode lead. It's just a metal tube that then inside that is the heater. But you got the plate, control grid, and your cathode. Then your tetrode, or 4-element tube. You have cathode, control, screen, plate. These are just two grids. Control grid, which controls the tube. Screen grid is used to reduce capacitance, internal capacitance in the tube, and then plate. And then you got your pentode, which is 5-element tube, cathode, control grid, screen grid, suppressor grid, and plate. And then there's other tubes. There's the pentagrid tube, where it has 5 grids inside. There's a hexode where it has 4 grids inside. And then you've got other tubes that will be like dual tubes in one glass, like a dual triode. You'll have 2 triodes actually inside the same envelope. You can have a pentode and a triode. You can have 2 diodes and a triode, and various different combinations. There's lots and lots of combinations. Now, some of the other stuff I didn't show on here is like switches and stuff like that, and as we go through the schematics, I will go through those and pick them out and show them out to you. We'll be looking at a Sears and Roebuck chassis 101.583, and I'll probably enlarge this even more, because even on 2 pages it's kind of hard to see. Another one is the Air King model A520. And I'll have to double check and see if these are, I think they're on Nostalgia Air. This guy, the Sears, is already on my Google Drive, so it's in there. It's underneath Sentinel. But this is just a simple, well, it would be actually an All-American 5, except it's new enough it does have a solid-state diode. So instead of a rectifier tube, halfway rectifier tube, to make up the 5 tubes, it's got a diode, so All-American 4, I guess you can call it. but it's based on that same thing. And then of course the other one is the Kaiser model, and like I said, mainly I want to just kind of show how some other stuff they draw in here, like how they do the tubes, and again about the resistors and the capacitors. They do some neat stuff with the capacitors and voltages. So I think that's about it for this one, and it's long enough anyway. So on the next video that I do, we're going to talk about this guy. So, known as, of course you've seen them more like this, where they have the glass envelope. This one's got a bad filament in it, so I decided to break it open, kind of discuss it a little bit, and so the magic eye or eye tube. So that'll be on the next video. So anyway, until next time, thanks for watching and thanks for being with me, and we'll see you on the next video.